let's do our second proof. We're going to make a 2-column proof with the property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and that AM is 1/2 of AB. All right, so here's my statements and reasons and my 2-column proofs and numbered. We're given M as a midpoint of AB, so you will start off with that. M is midpoint of segment AB. That's given generally where you start. Now, we want to think about what we know because it's a midpoint. Since it's a midpoint, we know that these two pieces are the same size. So let's start out by saying AM is congruent to MB. From that statement there, we derive this statement. That's the definition of midpoint. Now, because we've said that they're congruent, we need to state that that means they're equal. AM equals MB. Notice that the congruent and the segment symbols came off. So this is the definition of congruent segments. Now, because we've said this, let's talk about, we need 2 AMs, right? So let's talk about that AB is AM added to MB. So let's state AM plus MB. The AM plus the MB will equal the AB. That is the segment addition postulate. We'll abbreviate that. Now, because we've set up here that they're equal, and I need a 2 AM, I'm going to change that MB to AM. So AM plus AM, I substituted the MB here for another AM because I want 2 of them, equals AB. Now, when I substituted that, I'm using the substitution property of equality. Now that I have AM plus AM, I'm going to combine the like terms. So that's 2 AMs equals AB, which is part of what I wanted to prove. That combining like terms can be referred to as the distributive property. But often I'll just write combine like terms right there. And then if I wanted to prove that AM is half of AB, and that means I'm trying to solve for AM, I would divide by 2. And I'm left with AM equals, and you can write it as 1/2 of AB, which is exactly what that is, and that was the division property of equality. And we've proved exactly what they asked us to.